Actually, my title is The Social Network of Evolving Things. I'm Eric Pan, founder of City Studio, and I'm a stranger to this conference because most of my life was on hardware, and it's my first time come to the internet world. So, have you, has anyone in this room has built an IoT device before? Wow, many of them. So, and for those who haven't, you can get a hack pack and start to build your own. And everybody is talking about IoT, even teenagers is talking about IoT, but the common people hasn't adopted the technology yet. We don't see our friends using IoT devices. So there are actually several problems. First is how should a common people use that? What is the reason? What is the value we are creating? The second is how difficult it is to build IoT from all the hardware all the way to firmware to internet services. It's kind of difficult. Last year, we built a modular phone, which you can change the electronics, you can reprogram it, you can hack the mechanical part of it. And we learned that out of the many applications, the most interesting ones are those for non-human beings. For example, a dog corner, that you can make a phone call to a dog. You can text it to it and to know its coordinates. And why should not dog has a phone? Because dog might also wants to call its mom. It's just nobody does that because technology was too expensive for small volume for niche markets. But as we have more and more technology becoming more accessible, it's more easy for us to try to create new interfaces to objects around us. And we makers are trying to embed more technologies into objects around us, and we build the connections to enable them to connect with each other. So, for example, the dog has the ability to text back the coordinates, but he should also has a right to communicate, to interact with things around them. So we have more things connected, but there's no way we can deploy for 100 units in the room. We actually need a social network that links these things, so they can learn from us, they can interact with us, and benefit in a more automatic way. Let's go back a little bit to the history. We have laptops, we have computers, mobile phones for many, many years. They have been keep evolving. A lot of resources, a lot of innovations has happened within the screen. They become slimmer, they become smaller, and we kind of get used to the gadgets that they iterate each year. But meanwhile, we feel it's getting more boring. For all the smartphones, they look similar. For all the laptops, they look very much the same. So it's very natural that the innovations goes outside of the screens, because so many things around us, they are still ancient. They're still brainless. They are still not connected. So that's why everyone is efforting from going IT to IoT. It's a big leap. Oh, I have this. So if we look at things around us, they are not actually that difficult to hack. A few years ago, people started to talk about smart things because by that time the things has no brain. But we start to connect the light, we connect the socket with connectivities. We give them a microcontroller so it has some sort of intelligence. But it's not enough because you don't want to turn on the light by finding your mobile phone first and open an app and to find the right switch. It should be more automatic. It should learn from you. That's where we have more intelligent devices. Next, the thermostat is a good example of it. So the intelligence of the device is moving towards the users. It's learning from users, it's applying more AI. But it's still far behind human beings. But we are seeing a trend that we have more things around us. They will become more social. They will talk with each other. They will collaborate. They have much more info from different dimensions than we can have as a single human being. So if they combine together, their IQ eventually will be greater than a single human being. It's a bit scary, but by that time we can really benefit from the IoT. The big gap between internet and hardware and things, they exist for many years. That's why we heard IoT, I think maybe 20 years ago, and we keep hearing it, but it's still far from our life because the gap is still big. I came to the conference and I hear the talks and I found most of the talks I cannot understand because I program with C++. I do circuits, I solder, but you guys are working a lot on the script side. So as the huge gap is closing, the IoT is getting much real. If we calculate by the cost per connection, it's much cheaper. Like 5 years ago, if I want to connect my device onto the cloud with a GSM, it's much greater than $100. But now you can have a GSM module less than $10. And also you can program now with Python, with Lua, with all the languages you prefer because the computation power has increased. We can afford to have the extra CPU and RAM for your preferred interfaces. And also, we can see very soon with LTE, with all the devices, we actually can embed some laptop into a robot as things around us. So, and for hardware, I know people feel difficult as we see people passing our booths and feel, oh, what are these things? Do I need to break a circuit? Do I need to use a voltmeter? Actually, you don't need. It's very much like software now. Hardware is much slow, but we are learning from software. We are breaking the hardware into modules. You can just plug and play. They are open source, and you just need to know how to plug them into the sockets. So you can build a prototype very easily and have them functional within several minutes. And you can program with your familiar languages. They are at your disposal. And the W3C, which used to be the protocol for internet, now they have the Web of Things protocol. You can see it from the website. And as long as we have the network in things, they will build the access layer to enable informations and to find more components around them. And they can also share the information among each other. By then, we can compose the application to enable more conveniences. So we actually we are enabling the real world as a new API. We can see the door as an object. You can open it, and the door can notify things around them. And my door, I'm opened. But you can also program the light because it can hear that the door is open, so I should turn on myself. It's still API, but with all the hidden technology layers, you can actually access them as a very simple switch. So we can have more things connected, but we are very good used to buy new devices and throw them our way after a year. If we stand in the point of a thing, we feel very sad, but that's a survival mode. The technology products have been evolving, and it's selected by the human beings. We are keeping having a new product, and whoever fits will survive. If we look at a scale quadcopter, it looks difficult, but it can actually break into 4 layers. First is the brain. It's a microcontroller. It's the where brain is. Computation happens, and it also has a guard, the sensors. The modules can actuate. And it also has a skeleton, which can form the body and to shape the functions. But most important for you guys, I think, is the soul. How should we program it? How should we interact with it? What would be the most convenient way? For each of the layers, they are becoming more open source. We can have very popular controller board. We can have easy to access the sensors, but a skeleton, you have 3D printers, laser cutters. It's much more convenient than ever before that you can build your own devices. But the hardware is still hard. We see so many failures because we are having the wrong team. For software, because everything is standardized on the hardware, you only need to work on the souls. It's like a band. You can have 3, 4 people to start up a startup. But for hardware, you need the whole team. You need engineers, you need the quality insurance, you need logistics. You need so many people to help you to build the stack from bottom up. It's actually like an orchestra. If we form a band to play orchestra, that's going to be very weird, and that does not sound right. But there are solutions for the bands. The same as open source software, the hardware is becoming more open, and they are ready for the bands. This reminds me of my old times when I put together my own computer. You choose the CPU, you choose the main board, the sound card, the display, the keyboard, and you have a computer per your preference. We can do the same. We are doing the same for hardware now. You choose the most popular development board, like Arduino, like Raspberry Pi, BeagleBone Green, like you have Linked One in your Hackpack. But then you can just choose whatever sensors, modules you want, put them together. That's peripherals that carry out a certain functionality. And then you can go to the online community to talk with other people and to download their firmwares. It's already ready to use. And because these are open source hardware, the people are sharing actually the supply chains. They are optimizing the way to go manufacturing after that. And you don't need to worry that I don't know all the specific details of the circuits, because the community is working together to address that. As a hardware person, I'm very generous about software, because for compilation of a software, it takes only a few seconds or minutes. But for hardware, the compilation is taking a few months, even years. How can we facilitate that? How can we make it faster? With all the crowd designs, with all the open technology, you can already go from 0 to 0.1 very easily. But you need some help from the community who knows how to do the PCB layout, who can do the CAD design to go from 0.1 to 1, which is a manufacturable engineering sample. We call it the fusion samples. And because of the diversity demand, the manufacturing pattern is actually changing. It's much easier to manufacture just a few hundreds units. You don't need to be a startup. You can become just a very niche market experiment and get it going. And with agile manufacturing, we can go to 1,000 pieces. All this can happen in several months. And what we are trying to do is we manufacture 100 pieces in 24 hours, and it's working. The prerequisite is we use limited resources of components, and we try to work with each other to share the same supply chain. And after you've done that, you don't need to go through a traditional way of logistics and fulfillment distribution. You can just go to your social network, you approach to niche markets, and also your existing customers to give them new solutions. We are actually converting a supply chain business into a demand chain business. We accumulate all the demands, which is a totally niche market before, but we can, with a new business model, to support that. And they are very easy. You don't need to worry about all the hardware details now. This is our perception to the world. It's like a pyramid. There are so many people with ideas, they are dreamers. But unless they turn them into reality in atoms, they are the makers. They have the prototype. But as it goes on, they can make an engineering sample, like we said. There are more people that failed in this stage. But there are surviving ones who become the independent product maker. They are like independent music, independent movies. They have a small portion of user bases. Unlike software, luckily, you can very easily survive with hardware. If you make 100 units per year, you might have the income to sustain your team. You can be the 20th company in this business and still survive. But for software, you might need to stay number 1 or number 2. So we have better chance to survive if you have some hardware end to interact with IoT. If the market is proven, if you are lucky enough, you can go to hardware corporations. You can manufacture more than 10,000 pieces and to adjust to the traditional industrial resources. That's where you reach a new stage. And we have many more people building IoT devices. We see a huge base. And a lot of people use open source APIs, and they also choose to share what they made to encourage more people to improve that. It's become the gene that can be inherited. And the makers or programmers are never satisfied for what's existing. They bring mutations. So if we see the whole IoT devices, they are like creatures that keep evolving. I believe some of them will stay, some of them will survive and to become the next intelligent thing that might outbeat us. So we are trying to build the world as your new API, and you have something to start in your bag or downstairs. If you haven't registered for it, it's called the Hackpack, and you can also take note of us and Seed Studio. We have the sample ready, and we have a booth downstairs just by the entrance. We're happy to answer any of your questions, and I will be around just outside of the hall. Very nice to be around this conference, and thank you for the opportunities.